Hopefully you can all hear and see me okay. I'm stuck with the vagaries of hotel Wi-Fi tonight, which isn't always the best. As Jamie said, we've got a very interesting evening for you as ever, and thank you all for taking time out your evening to join us tonight. I suppose initially just really want to say thank you to the industry leadership group and Confor for supporting these meetings and helping drive forward the industry and getting everyone together to discuss important topics for our sector. We've got 3 very good presentations tonight, and also you'll have hopefully seen attached to the email that Jamie sent out updates from Neil Murray, the Conservator for South Scotland, and also Jamie's update on the general Confor activities. We're going to have I suppose, a question and answer session after the first presentation tonight because it's slightly different topic to the 2 others. So we thought it was worth having a short question and answers after the first session. So if you've got any questions for the first speaker, please get them in quickly. And then we'll have the second 2 presentations, which align nicely, and another question and answer session after that. So our speakers tonight, first up we've got Andy Baker. I'll introduce Andy in a bit more detail in a minute, who's going to give us an update on the Woodland Carbon Code and the changes to the additionality, or proposed changes to the additionality tests. Following that, in the question and answer session, we'll have presentations from Nicole Sinclair and Ben Crisford, which is more touching on technology and the use of technology in the industry and how we can use it and how we have been using it and potential future uses as well. So with that, I'll introduce our first speaker tonight, who is Andy Baker. Andy works for the Woodland Carbon Code / Scottish Forestry and is the UK Woodland Carbon Market Advisor. And as I said before, Andy's going to give us an update on the Woodland Carbon Code and changes to additionality. So with that, I'll hand you over to Andy.
Marvellous, thanks a lot, Eddie. So yeah, I'll give you as much of an update as I can since the last meeting. A lot of it in the interim period has been consultations, reviewing the different options we have, but I'll go into more detail throughout the presentation. So first of all, just to look at the current market itself and see how the carbon code is getting on. Not to teach or to suck eggs, but I think it's always useful in these sort of presentations to touch on the key principles behind the credibility of carbon credits and leading on to why additionality is so important. Next of all, just looking at what we've done so far. I mentioned the consultation process and that sort of thing already. And then after that, as Eddie touched on, the proposed changes. I don't want to spend too long on this, no more than 10 minutes or so, I hope, so that we have as much time as we can for questions at the end. So first of all, just a brief outline of where we are with the current market. So the figures in red are current figures and the figures in blue are figures from 3 months prior. So this map and these figures were drawn from our quarterly review at the end of December last year, and the ones before that were 3 months prior. So you can see the interest in the code is rapidly expanding, and we're covering far more of Northern Ireland and more remote areas of England as well, down to the Isle of Wight and that sort of thing too. The darker the colour of green generally indicates the further along it is in the Woodland Carbon Code process, registered, then validated, then verified. So gives you a bit of an idea to the scale of the Woodland Carbon Code and where we're hoping it's going to continue to be. So next of all, just looking at the key principles behind carbon units and voluntary carbon markets internationally. So first of all, we need to make sure it's measurable. So when you're looking at generating these carbon units and designing carbon standards, I know a lot of you have heard about different carbon standards coming out, hopefully all being developed, hedgerow carbon codes, soil carbon codes and that sort of thing. They all need to be measurable. So for us, it's quite easy with mensuration and that sort of thing, whereas with peatlands, with soil, it can be a bit more complicated. Next of all, it needs to be permanent. Now, there are conversations pushing for the permanence of carbon units to be in geological timescales, thousands, tens of thousands of years, whereas we in the Carbon Code, Woodland Carbon Code, and the general consensus internationally is that 100 years is a reasonable amount to be classed as a permanent removal of carbon dioxide out of the atmosphere. Next of all, it needs to be verifiable, and this again is just following on from that measure. It's kind of building the two before together into ongoing verification to make sure that the woodlands or whatever the nature-based solution is consistently sequestering as much carbon as expected, and then they have to be additional. All of these build into that credibility of the carbon unit, and that credibility is why people invest in it. If you didn't have that, there'd be no market there. So why is additionality important? So this is a bit of information about carbon additionality generally, and it goes back beyond 10 years ago for the Kyoto Protocol and protocols before that, when the voluntary carbon markets were really taking off. Essentially, it's asking the question, in this scenario, would the woodland have been planted regardless of carbon finance? Would you have gone ahead with it anyway? Now, of course, that is an impossible thing to ask and to prove because it's a counterfactual. However, this is what we're trying to achieve and what we're trying to test through our different additionality tests. Now you can see at the bottom there are over 15 different types of additionality tests, technological and cultural and that sort of thing, but we focus on just 3: the legal test, the financial test, and the barrier test. I know that's kind of misleading because we currently have 4 tests. We have the legal test, then the contribution of carbon finance, but that's kind of brought into the financial test as well. It's just a different approach to that. And then the barrier test. So digging into a few little scenarios that I thought might be useful. And again, apologies if this is a little bit simplistic or patronizing. It's not meant to be. It's just I find this a really useful way of illustrating the need for additionality. So a lot of people say to me, well, all trees sequester carbon. Why can't we just say, if you're sequestering carbon into a woodland, right? Can everyone else see the picture, or is that just Ron? I'll carry on as though everyone else can see it unless someone tells me otherwise. So where was I? Yes. So when it comes to, surely every woodland is sequestering carbon, can't we just give carbon units to all of them? And companies can invest in those woodlands and they can support woodland creation. Surely that's the way to go. That makes sense, but what we're trying to do is act as a facilitation mechanism to unlock more woodland creation than would have happened otherwise. So if you're just funding woodland creation that would have happened anyway, it's not going to help. So in these 3 scenarios, I basically outlined the 3 different types of woodland creation from an additionality perspective. So compensatory planting, and let's say all 3 of these are 100 hectares and they go up in scale of cheap to expensive units. So if we were in a scenario where we had no legal test and no financial test, and we had a pot of money from investors looking to invest in carbon finance, well, naturally, if they're just wanting to be able to claim carbon neutrality, they're just going to buy the cheapest units. And so essentially, because you're only going to be getting compensatory planting, so no net gain in woodland creation there, that's just replacing what's already been lost, and it's economically viable, so you're going to get this as well, whether that money goes there or not. You're not going to get this third option, the non-economically viable option, and the units are too expensive. The total new woodland creation is 100 hectares just from this economically viable option. If we were to change that and say, okay, well, we are going to have a legal test because, you know, compensatory planting, you have to do it anyway. You're legally bound. You have to do that. And so let's look at the I should stop trying to read the questions as they come up as I'm presenting. So the next option for the investor would be to go to the next most expensive units, to the moderately priced units, again, funding economically viable woodlands that would have happened anyway. Net woodland creation, again, only another 100 hectares extra. If you go and include both of the tests, and so this is the difficulty, trying to define what is economically viable and would happen anyway in comparison to what is uneconomically viable. That doesn't mean non-economically viable. The money would have to go there. That unlocks this woodland creation. Our total new woodland creation now is 200 hectares. I know that that doesn't necessarily happen on the ground nearly as simplistically as I've described, but that is the premise behind why we're doing additionality. We're wanting to unlock woodlands that wouldn't have happened otherwise. So moving on from that, what we've done so far with our additionality update, First of all, we've conducted our own internal reviews and summarised our findings. We've summarised those findings with both our executive board and the Wood and Carbon Code Advisory Board. Now, CONFOR are a part of that, as are the ICF and lots of other organisations involved in the code. We also have created an Additionality stakeholder engagement group, which a lot of you may know, and in that group, again, project developers from the Wood and Carbon Code, and we have been speaking to them about the proposed changes and different suggestions they might have. We've commissioned our own independent reviews, and we've also liaised with investment advisors, landowners, corporate buyers, everyone under the sun at this point. I can't tell you how many conversations I've had about this. So we've done quite a bit on it, and now we have come to this final page, essentially just outlining the proposed changes that we're making. So there are a variety of factors involved in assessing the financial additionality of a project, and the main way we do this is through a cash flow document that we currently have. Now, for the last 10-11 years, we've essentially said to people, just fill it out as accurately as you can, and it will therefore determine whether you are additional or not. The fundamental flaw in this, more than anything else, is that when land purchase is involved, we allow for that land purchase to be used as a cost in year 0, year 1, and as an income, the same value as an income at the end of the project, say year 100 or so. That final value is then discounted back over 100 years. So if you bought a piece of land for £1 million, in your cash flow and your net present value, you would have £1 million as a cost in year 1, and then you'd have discounted back at just 3%, that same £1 million worth of income is classed as £55,000 as an income stream. So what that means is that regardless of whether someone was trying to fill out this spreadsheet as accurately as they could or not, including purchase price makes a mockery of the whole system, because every single scheme, doesn't matter what you've planted, doesn't matter how much grant you get, doesn't matter how many donations and tree sponsorships you get, you're going to pass additionality. So something had to change. So we tried to replace that with a proxy to say, well, what is the land worth? We can't use purchase price, so we've looked at rental values and we've looked at income foregone values. We've spoken to a lot of different people about this to try and find the right metric to use, the one that's most consistent and accurate. And we are basically still ongoing with that to find the exact right metric to use. We're definitely not going to be using purchase price though. Next of all, we're looking to set or cap the discount rate. I've already mentioned that 3% discount rate over 100 years. At the minute, you can use whatever you want. And so this is where it's important for us to make sure that for consistency across projects, there's something in place to say that you can't go higher than X or Y. Next of all, we're looking at standardizing certain figures, including that income foregone and rental values, and we're drawing that from the Farm Business Survey. Timber price, we're basing that on standing sale indexes for the price, grown in Britain for some hardwood data, forest yields for the sort of yields we're expecting to get as well. And so hopefully this can help standardize that process again. And then finally, looking at a carbon price, because even though that doesn't necessarily affect the additionality calculator, because we're not really interested in how much carbon money you're making, we're wanting to compare, well, how much money would you make from a farming scenario? If that is more than a forestry scenario without carbon, then we will give you carbon. You are additional. Whereas if you increase, the reason we're increasing the standardization of a carbon price, what we're wanting to include is some sort of transparency to buyers about where your income is coming from. So they will be able to see just on a pie chart on your project design document, they'll be able to see, okay, well, you're getting 30% of your income from timber, 40% from grant, and another 30% from carbon that they're contributing. So they can make a more reasoned and informed decision about funding that project. They want to know how much of a material difference their money is actually making. And that is essentially it for today. So we're hoping to make an announcement at the end of this month. We are hoping to get all of the calculator and information out by that point. It may have to roll over into April if we can't make that deadline, because we are making sure we've gone over everything with a fine-tooth comb. But that's the target. And then what we're hoping to do is to have the deadline for using our current additionality rules for September 30th of September this year, to basically say that any project up until that point that has been planted and the validation documents have been submitted to the validator will be able to use the old rules. Any project that is doesn't meet either of those criteria before September 30th has to use the new rules, has to use our new standardized spreadsheet. So that is essentially all I was going to give, Eddie. So I am more than happy to have a chat through any questions that people may have.
Thank you very much, Andy. We've only really got one question and one point so far. If there is any more questions, please stick them in the chat. First up is a question from Chris Hill. Does any other organisation operate a carbon credit scheme in Scotland, such as Vera.org? Has Confor considered setting up a scheme to support the commercial growers to support the future industry?
So the second point, I guess, would be for either Jamie or yourself. For my side of things, no. So far as I understand, Vera, Gold Standard, VCS, they don't operate any woodland creation schemes in the UK. I don't know whether they operate any other types of carbon schemes, but as far as I know, the only carbon crediting schemes that are UK government backed and DCROA endorsed in Scotland and in the rest of the UK are the UK Woodland Carbon Code and the UK Peatland Code.
Thank you. Jamie, Andy, do you have any comment at all in the second half of the question?
No.
I thought that would be the answer.
I will defer to Andy.
No, it's not something we've thought about. It's maybe a bit out of our remit, but if it became a situation where it was becoming extremely difficult to get productive forestry planted, then maybe as a greater industry we'd have to look at something, but not at this moment.
No, thank you, Andy. I think you've got off relatively lightly there, Andy, in terms of questions.
Absolutely. Just on Simon's point as well, that's Simon in the Simon Stewart. I'm glad you mentioned that, because that's initially how I had it about, in my scenario, 300 hectares being planted. But I was talking about net new woodland planting. So in the compensatory planting, that first 100 hectares isn't classed as new woodland creation. So that would happen regardless. That's net zero. And it's that economical scenario is 100 hectares, and then it's only with carbon funding that third scenario is another 100 hectares. And don't apologise for being pedantic. I'm as pedantic as the next guy, so I hope that clears that up.
Yes, I spoke too soon that you were getting away easy. Another question in from Emma Kerr. Using the Farm Business Survey data as the proxy for standardised foregone income indirectly means that planting on better agricultural land will more likely be additional. With the current press surrounding food security, what are your thoughts on how this will impact the WCC?
No, it's an absolutely fair question, Emma. So yes, you are more likely to pass additionality with higher rental prices based on the nature of woodland creation, in the sense of, from an economic perspective, it's going to be harder to justify woodland creation from an economic perspective on higher quality land. Now, when it comes to the real high quality land, we're talking about grade 1 and 2 quality land, woodland creation is going to be a hard sell even with carbon units. And so unless the carbon market was to change dramatically and the price of carbon units was to increase significantly, we don't see that as being much of an issue. We've run a lot of different sensitivity analyses to see what would make sense from an economic perspective based on these different categorizations of farm type and farm yields. However, if we ever are in a situation where we are really, the carbon price has shot up to 100, 200 pounds per unit, and we're realizing that we are threatening food production, we can simply say that we don't allow for carbon schemes to be used on higher quality land. So we can just red list woodland creation with carbon units. Obviously, we can't say you're not allowed to plant on higher quality land, but from our perspective, if we really are concerned that food production is threatened, then we can say, well, you're only allowed to plant up to grade 3 land, for instance. So that's a kind of backup option, but from the analysis we've run, that's not going to be a problem for quite some time.
Thank you. And final question that sneaked in from Simon Jacina. Are you concerned that changes will distort the market artificially and artificially encourage native rather than productive conifer planting?
I'm not, Simon. I used to be, but I'm not anymore, and I'll explain why. So, which I assume was your intention. So first of all, when we are looking at if you were to say, I'm going to plant 100% broadleaves because of the carbon price, that's putting all of your eggs in the carbon basket. Whereas if you plant a mixed productive, some native, some mixed conifer woodland, you're resilient against climate change, against timber prices, and against carbon prices. So if a new technology was to come out that almost made carbon sequestration through woodland creation negligible or unnecessary, then the carbon price may plummet. If there are other technologies like DACS, direct air capture, was to really develop quickly and the price of carbon through that was to plummet, then the carbon price won't continue to increase. And so someone planting just mixed broadleaf woodlands or just native woodlands or allowing natural regeneration to take its course purely from a carbon credit perspective, they're taking quite a risk because they're putting all of their eggs in that basket. Secondly, when it comes to the generation of carbon units, let's say we had a completely mixed native woodland and that was going to sequester over 100 years, 500 carbon units, whereas a thinned Sitka spruce clearfield project was only going to generate 150. Okay, well, you're only generating 30% of the units, but the vintage of those units are going to be coming far sooner because Sitka spruce grow so much more quickly. And so the value of the fewer units you have are going to be so much higher than those larger quantity of lower value units from the mixed broadleaf perspective, purely looking at it as a vintage thing. So when I say vintage, I simply mean the time that we predict, or the date that we predict those pending issuance units that we assign to you are going to convert into WCU. So if you have a Sitka spruce project and you're expecting all of your carbon units, even though you're only generating 150 per hectare, to convert into WCUs by 2050, they're the ones that companies are looking to buy. They don't care about units that are converting in 2100 because they want to make a carbon neutral claim by 2050. And so you not only get the benefit of the timber revenue and, as I say, the resilience for all of the other climate change reasons and that sort of thing by planting a bit more of a mixed woodland, you're also getting that higher value carbon units earlier.
Thank you, Andy. There's last time you put a point in and there's another question from Ian Pettifer. Is there any chance you could just answer that in the chat, Andy, because I think we'd better move on to our next speakers.
Absolutely. No, I'll pass back to you now, Eddie, and I look forward to the next speaker.
Thank you very much. Yes, next up we've got Nicole Sinclair, who from Forest Research. Nicole is the head of IFOS. I had to look up what that was. I'm about to say it's the Inventory Forecasting and Operational Support. I think I'm right to say, Nicole?
That's correct.
Good. And Nicole's going to give us a presentation now on the current and future uses of satellite imagery. Over to you, Nicole.
Okay. Can everyone see my screen?
Yes, we can see that now. Yeah.
Yeah. Okay. So Jamie posed me this question. So obviously we've got a relatively short time. So I'm actually just going to explain up front that we've got work going on in these kind of 4 key areas: regulation, tree health, forest operations, forest planning. Some of you may have seen some of our work already, particularly around storm damage assessment. I'll draw out some examples as we go through that. There's a couple of areas in here: restock colonisation monitoring and the hyperspectral identification of stressed trees. That's very much still, well, the restock monitoring is actually past proof of concept, but the hyperspectral identification of stressed trees is still very much a research experiment. But the rest of it we can do in some form or fashion and are already doing with various customers. So the other thing I wanted to say up front is once we get into this kind of technology, it's got implications for how we see things. So we're clearly moving from a static to dynamic data. If you look at the subcompartment database used by the state entities, much of that information hasn't really changed for 20 or 30 years. But now we've got satellites passing overhead every 6 days. We've got other satellites we can commission in, and then there's various other things that we can do as well. for sure it's going to recalibrate how we view and understand forestry data and information. But as always, the data quality, the RIRO or CISO, depending which an acronym you want to use, will call into question. The other thing that's important in there is and certainly in GB, is devolution. Each country's going its own way, and I'll come back to some of these points in my talk later on. Skill sets to turn data into helpful information. You do need data scientists. Some of the data that we're handling now isn't that helpful to use. It's really quite difficult data, and clearly, once you're into managing big data repositories, you need suitable storage, processing facilities. And when I say cost implications, I suspect a few of you will think I'm talking about it's very costly. Actually, the biggest cost is getting the data, and a lot of that data is coming to us free at the point of use. So obviously there's kind of 4 key ways we get information. I'm going to broadly stick to satellite, but I'm going to touch on LiDAR, which is captured by fixed wing aircrafts, either planes or heavy duty drones. And satellite, most of what we're using is Sentinel information. So there are 4 Sentinel satellites, Sentinel 1A and 1B, and Sentinel 2A and 2B. Pretty straightforward. Sentinel 1 is synthetic aperture radar, for those that know, apologies, but it's high density microwave essentially. Very difficult data to handle, but it's very good at seeing through cloud. Sentinel 2 is optical hyperspectral, and it's not quite aerial photography standard, but it's still very good. Both of them are around about 10 megapixels. I will touch on the LiDAR later in my talk, because I think when used in combination with satellite, that's going to be really quite powerful. Drones are obviously been touched on, but also just to say we're now using GeoSLAM handheld LiDAR sensors as well. So we are now starting to actively use them too. So what are we talking about here? So here's an image using SAR satellite data to detect felling across Scotland. We do this now for Scottish Forestry and have been doing that for about 18 months. And that's the kind of imagery and product that we produce. As I said, it's done with SAR. The reason we use SAR is because it's very good at seeing through cloud. We also use time series imagery to make sure that we're getting a good, accurate result. We have a couple of packages, bronze and silver. The bronze is done with artificial intelligence, machine learning only. We then use Sentinel-2 data with human eye to do a sample of the data to come up with some confidence limits about how accurate the information we're producing is. And that's proven to be very effective. So we can now deliver regular information about woodland loss across Scotland, and have been doing that, as I said, for about 18 months, and very much hot off the press. England have said they want to take this product up, and I'm in active dialogue with Wales about the same. Now, interestingly, in relation to Confor members, Stuart Goodall approached me about a year ago and asked if we could do something to ascertain the amount of felling in pipeline across Scotland. So we had a discussion internally, and we put a proposal to Stuart, and I've been talking to a subgroup periodically over the last year. And we did a pilot in South Scotland, which is actually where this image is taken from. And we've then extended the pilot to the whole of Scotland. So I'll maybe explain some of the data issues here in a wee minute, but I'll just give you the slide. So what we did is summer to summer 2021, as I said, there was just over 17,000 hectares we assessed as having been felled across Scotland in a year. Those that were felled within licences was 5,200. Felling outside licences was 12,000. And before everyone wonders, I'm sure you're all aware there's different kind of licences, and obviously FLS land at the moment isn't within the felling permission system. Apologies, not licences. And anyway, what it all comes down to is the bottom line, and you'll home in and you'll think, jings, there's 2,800 hectares being felled without a permission. Well, that's not strictly true. In fact, it's probably not true at all. So what we know for a fact is that Scottish Forestry, because they've told us, don't routinely put in any felling amendments into the felling permission layer. So of that data set that we were using, we know there's no amendments in there. We also were told in advance that the statutory plant health notice layer wasn't routinely kept up to date, and therefore we couldn't get accuracy. And then the other thing is that any felling that's done through some kind of felling permission would have been captured in here as well. So although I can't give you definite percentages of all of that, we were quite content, having looked at the data, that there was no mass scale impropriety. But it does just give you a sense of how understanding the data quality. And again, hot off the press today, Stuart wrote to me to say that we're now actively going to be discussing with Scottish Forestry how we can improve this so that we can run the figures and get a much clearer sense of what's going on. But I thought that was useful to show you, just to give you a sense of how we've combined the felling permission layer data and the woodland loss algorithm to come up with sort of the amount of felling that's been done annually and how much of it's been done within planning permissions. And I've got the figures, but we've now actually supplied Confer with a pipeline figure for Scotland, and we're going to move on to England next financial year, apologies, with this as well. So the intention is to move on to Wales as well. So we'll have this kind of information across GB. There's other methods that we can use for monitoring felling. This is the hyperspectral. This is the red, green, blue bands. And if you can see my cursor moving, you can see there's a June image, there's an October image, and you can quite clearly see the change in colour here. And this was something that we did. I think the area here involved was about 1.5 to 2 hectares, relatively small piece of ground, just trying to understand when it was actually felled. And here we have in the near red infrared, again, you can see the reason that this right hand slide showing a slightly lighter red is because it's October, and obviously the leaves are starting to turn, but you can still quite clearly see where there's where woodland loss is taking place. So I thought it would just useful to show you that obviously that we can use both Sentinel-1 and Sentinel-2, but particularly in Scotland, Sentinel-2 is very difficult. And again, I'll show you a slide later on, particularly once you get into the winter months, it's really pretty much no use for this kind of analysis. We've done an awful lot of work on species mapping. As part of natural capital ecosystem assessment work with DEFRA in England, we have a genus map which will be published early in the new year, which has spruces, pines, larches, etc. for England. And we have been showing that to customers in Scotland and Wales to see if there's interest in doing it there. But this is a particular piece of work that we did. It was kicked off by the Welsh Government, who were really keen to understand how much larch they had left in Wales, so they could understand for their Phytophthora ramorum flights and work just exactly how much potentially problem larch they still had to deal with. But it's really quite. I'm actually very pleased with this product. We present information as a probabilities, and this goes back to I'm saying calibrating how you see the information. The top left-hand screen there shows you hybrid larch, Japanese larch. Obviously, we can't discern the two, but it does show you a kind of heat map. And because these are 10 meter pixels, where obviously there's a join with another crop, you'll see that the probability goes down. But as I said, once you dial into it, you can quickly see exactly what's going on, that's the boundary of the larch and, in this case, Sitka. And you can also see that the subcompartment database is wrong here, because there's this spruce intrusion in here, which is picked up off the satellite imagery. So that's done sort of on 10 meter pixels, and you can obviously see the pixels on the imagery there. Here's another one, same kind of thing, but again, you can maybe pick out where the subcompartment database, you can see there's some spruce in there for the more eagle-eyed of you, which has been picked up here by the satellite imagery. So we're actually speaking now with some operational people in Scotland about using this to validate the information they've got in the subcompartment database. So that we're speaking to somebody over in the West region about that. And then I'll move on to wind blow assessment. I'm sure nobody's missed out on the joys of Storm Arwen, and that's an image caught of the portal, a screenshot, and that's a piece of work that we were asked to look at by both Scottish Forestry and Forest Services in England just after the storm occurred last year, and we were able to get some quick data to identify the epicenter of damage essentially 2 or 3 weeks after the storm. Again, we used SAR imagery to do this. We knew at the time we had an issue catching some of the smaller fragments of damage, and I think the more we've had a look at the storm, certainly in my experience of major wind blow, particularly a wind of that kind of ferocity, it's shown up to be a slightly unusual storm, and I'll maybe just go on and explain that to you. So I was in Argyll in the 90s when the Boxing Day storm of 98 hit, and this woodland that is on screen is called Dalbuie, just south of Campbelltown. And the areas highlighted in yellow there were what came down in the one night in that storm. The woodland itself, I think, is about 4,000 hectares, and the area in yellow is about 500. I mean, it literally was somebody just put some kind of massive bomb over the woodland and completely flattened these sites. There may well be some folk in Egger or Euroforest online who were involved in the clearance of that woodland, but it was catastrophic and devastating, but it was big damage. What we've noticed with this storm is, I think the biggest individual clear fell we've found is about 30-40 hectares. But this is Cardrona woodland up in the Tweed Valley, which illustrates quite nicely the kind of damage that we've found. And I've been asked about whether we can publicise. We've just revised the algorithm and we've run new numbers, and I'm afraid I'm not able to share the new numbers with you. But if I can say that, if for those that you are more spatially aware, if you can work out the percentages here between this magnolia colour is what we found in the original analysis we undertook back in early December, and this sort of bluish colour and this sort of lilac colour is what we think we've found since. You could probably get a sense for what the additional damage is. So when we run the first algorithm, we're really looking for epicentre of damage. The reason that we were trying to do that is we were very cautious with the thresholds that we put on the data. We had hoped that our woodland loss algorithm would be able to find wind blow, but it was actually no use. And so we had to develop a whole new algorithm. We've subsequently, with the portal, had a lot of feedback about areas that we've missed, and so that's allowed us to refine it. And then that's picked up these other blue areas here. And as I said, we depending where you set the thresholds, we could potentially pick up a wee bit more. But the higher you set the thresholds, the more false positives and false negatives you'll get. So, like everything, it's a bit of a trade-off. But that gives you a sense of where we started last November. And then all this other areas that we've picked up is kind of where we're at now. And if anyone asks me a question to try and speculate what the additional damage is, I'm afraid I won't be able to answer it. If you wonder why we don't use the Sentinel-2 imagery, this is the same woodland. About the same time we did analysis, you can certainly see some storm damage, but you can see there's whole parts of the hillside in damage, in shade, whereas the SAR satellite imagery can actually get through all of the cloud cover and pick up the areas that have been damaged. One thing I'll say about SAR as well, it's very fussy when it comes to moisture, and we'd noticed particularly in England in farm areas we're picking up some false positives, so it is a fairly difficult data set to work with. And I will just maybe tip into LiDAR here. This is a LiDAR image of trees outside woodlands. We're going to also be launching a map for England, which will show all the trees outside, woodlands, hedgerows, etc. It will be keyed, but it's based on a combination of satellite and LiDAR data that we've got across England. For those of you who are not aware of it, the Environment Agency in England embarked on a programme to get LiDAR coverage for the whole of England, and that pretty much completed last year. I think they're up about 85%. Wales have started their LiDAR, national LiDAR coverage. I think they're in the second or third year, and Scotland are still lobbying ministers to get Scotland covered. Why this might be of interest to you? Well, what we're able to do in England is start to look at different metrics for trees. So the image there on the right hand side is a traditional GIS image from a standard database. The image on the left hand side is what you can do with LiDAR, and clearly you can see the yield class scale here, and actually what it represents more accurately is what is there actually on the ground. And when you then combine that with data sets like the satellite imagery for storm damage, we can do things like this. So this is analysis we did for Northumberland Forest Park, or yeah, I think it was Northumberland National Park, actually, not Northumberland Forest Park. Anyway, it was for that area based on our first cut analysis of Storm Arwen damage. And you can see the kind of volumes that we discovered in there by species. This was done for Kielder Forest District based on their subcompartment database. So this doesn't include the private sector in that area. And this down here is the average tree height. So you can see the average is around about 30 metres. So Arwen took out some big trees, and we're seeing that replicated right across the whole area. It tended to have taken out much more of the bigger trees than perhaps would have been the case if it had been the West Coast. So that was really just a whistle-stop tour. I'll come off sharing now, and I think I'm handing over to somebody else, and then there's questions and answers. Is that right, Eddie?
That's correct, Nicol. Thank you very much for that. Yep, we've got Ben Crisford up next. Ben's a forest manager based in southwest Scotland with Tilhill, and Ben's going to give us a presentation on drones in forest management. Over to you, Ben.
Yes, yeah, that's right. And actually, yeah, thanks for the presentation, Nicol. Mine actually ties in really nicely, and we didn't collaborate at all beforehand, so good news. Get the screen share set up. So yeah, hi everybody. My name is Ben Crisford. For those who don't know me, I work for Tilhill. I'm a forest manager. I'm going to be talking a bit about drone use in forestry, and kind of generally. I'm also going to focus to begin with on Storm Arwen. And I'm very aware it's a subject that's been covered a lot over the last few years, so I'm going to do my best to bring some fresh perspectives to it and try and keep it interesting for everyone. So yeah, we'll start by having a talk about Storm Arwen and how we use drones in the response to that. So there we go. So sadly, this is a site that's will be familiar to many of us. This is what we woke up to on the 26th of November, and it's large-scale, multi-directional wind blow, often with a significant stem snap component as well. And we've heard from Nicol how his team were a great help to us in quantifying the extent of the damage, but there was still a lot of work for us to do ourselves, and unsurprisingly, that's where drones played a really important role. So I think, from my perspective, drones help us with that initial wind blow survey in three key areas. So firstly, I think we all know that walking around an area of wind blow is fraught with difficulty, and the drones give us this unique ability to do that without putting ourselves in harm's way, which is clearly really important. Secondly, often we find following a big storm event like Arwen, we actually can't get close to affected compartments because of obstacles on the forest road. And drones are obviously less constrained by these. And thirdly, drones are a really time-efficient way of covering a large area and quickly determining presence and absence. it's easy enough to drive around a forest and see areas that are visible from the road, but there'll be other areas that we'd potentially have to walk a long way to get a vantage point into. And using the drone gives us that comfort that we've identified all the areas we need to worry about from a kind of management decision perspective. In this example here, we're looking at a large-scale commercial forest. It's about 1,000 hectares in size. And we eventually found we had over 100 hectares of windblow from Storm Arwen and the subsequent storms. But using the drone, we're able to quantify this in a really short space of time, just in a matter of hours, by focusing the effort on areas of recent thinning, areas of over mature crops, and areas where there was existing windblow that could have extended. But crucially with the drone, as well as taking pictures like this, which are great for kind of updating clients and using as evidence for felling permission applications and plan amendments, we're also able to map areas with a high level of precision. So we can stitch our drone pictures together. We can process them into a map like this one, which we can take measurements from, and we can pull it into GIS and use it to update our compartment records or inform insurance claims. And we're able to react, really quickly and agilely, if that's a word, and get our felling permission applications in, at the front of the queue almost. So in conclusion of my windblow segment, the drones allow us to map areas of windblow without putting ourselves in harm's way, into a high level of precision as well. We're able to check much more quickly for the presence and absence of significant windblow, and we're able to get to those areas which we wouldn't be able to get to otherwise. As promised, I'm also going to talk about some other exciting applications of drones. And I'm also going to touch on LiDAR as well, so it's quite useful that Nicole did some of the explaining for me on that. Well, I'll start by talking about kind of where I see the state of drone use in forestry at the moment. And I'd say, kind of broadly speaking, foresters in the UK fall into one of two camps. There's kind of enthusiastic adopters who are really excited by the technology and want to see what it can do. And there's more reluctant adopters as well, who quite rightly, I think, want to see drones pay their way and are potentially only interested in a limited number of use cases. So windblow surveys, quantification of ground prep, probably chief among those. And I think in reality, we need both those groups. We need the enthusiasts to come up with new ideas, and we need the skeptics as well to keep our feet on the ground, make sure what we're doing makes sense from a cost-benefit standpoint. And ultimately, the best solutions appeal to both those groups as well. And I'm going to share one now, which I think has potential to be another one of those core use cases. And it's not one that we hear a lot about, and probably for good reason, because there's, I'll explain why in a second. The one thing that we're able to do with the drones, as well as stitching images together into a 2D map that we can take measurements from, we can also produce these 3D models, and we can measure surface features from them. But with the kind of drones we're using in forestry in the UK, there's an important limitation, which is they've just got an ordinary camera and they can't see through the trees, which means although we can model the terrain in 3 dimensions, we can't model the terrain we can't see, and we can't see the ground level under the canopy. And clearly that's a barrier to mensuration, because to measure the trees, we need to know the height at the top, and we need to know the height at the bottom, so we can work out the difference between the two. So we can do that with a LiDAR sensor, a very expensive LiDAR sensor, but we can't do that with the kind of drones we're using at the moment generally. But there is a workaround, and Nicole shared with us how IFOS are using LiDAR data increasingly. It's something we use a bit at Till Hill as well for yield class assessments, because for those who don't know, SEPA have also made LiDAR data available. And it's under an open government license, so we can use it with attribution, and this can plug the gap in this drone example. So we can combine this detailed terrain model of the sub-canopy terrain with our drone model, and we can produce something like this, a canopy height model. So this is that same compartment that was pictured previously. We've got the darker blues denoting taller trees, and the lighter blues and the paler colours are the shorter trees and the other surrounding vegetation that's been picked up as well. And this is an area that would be it's fully covered by the LiDAR data set. So we could take the tree heights from the LiDAR as well. But what we'll find is the LiDAR data will give us that fixed point in time. So say the survey is dated 2015, that's 7 years ago, and this is a crop that's about getting on for about 20 years old. So it's useful to have that impression, but really that when the trees are at that height, the yield class curves are so tightly bunched, we're not going to be able to extract that much meaningful information from it. But by combining it with that drone data as well, and comparing the two, we can interrogate it so that the image on the right is a zoomed in version, where a forestry user has clicked on the map and GIS is telling us what the tree height is at that point. So clearly we can use that to really reliably determine yield class. We get this really detailed picture of the productivity of the stand, and we can use that to inform management decisions, most likely about thinning. So it's a really useful tool, but at the same time, it is limited at the moment, not least by LiDAR coverage. So this map shows roughly where we've got LiDAR data available in South Scotland. Actually, as you go further north, there's very little coverage at all. And almost regardless of where the coverage is, should we rely on that data being perpetually available? I hope it will be, but I think a better alternative is if we can capture that data ourselves. Now, none of us want to go and spend tens of thousands of pounds on a LiDAR sensor, but the reality is we actually can capture that terrain information with the cameras that we have in the same way that we capture the canopy data. We just have to do it at a time when there's no trees in the way, which means at time of restocking or at time of woodland creation. So what I'm often saying to people is, for whatever operational reason you have for carrying out a drone survey on a restock site or a woodland creation site, what you're also getting for your money is this baseline site data that is, you can essentially think of as a data asset. This is a 3D model which has future value. It's going to pay off in 10 to 15 years down the line when you decide you want to measure something from it. I think it's not quite as simple as that. I think there's questions that we should be asking about if we're going to be using these data sets for future mensuration. Do we need to change the way that we're capturing them and make sure we're using things like ground control points so we can tie different data sets together really effectively? Because I think I recognise that it's almost a risky manoeuvre, kind of combining two sources of data, because you're potentially kind of compounding the error in those two data sets. But regardless of that, I think it's an exciting kind of emerging area. I think it's something that we're kind of undervaluing at the moment. The sort of residual value in the drone data sets that we're capturing after we've kind of extracted the information that we want, and we file them away and forget about them. So yeah, to conclude my presentation, I've talked about how drones are helping us solve practical challenges and driving efficiencies. The response to Storm Arwen was a really good example of that. Quantification of ground prep is another. But I think something we often overlook is, at the same time as giving us those operational efficiencies, drones are also providing us with this baseline site information, and some of it is potentially really valuable in years to come. And I think if there's one message that I want people to take away from my talk, it's that there's an opportunity cost associated with not capturing sub-canopy terrain data at the one point in the rotation, and there's no trees in the way, and we can do it at relatively low cost. And that's me. Thanks very much for listening.
Thank you very much, Vince. This is an thought-provoking presentation. Probably should have been capturing images for the last few years that we haven't, but still. Yeah, welcome Nicol back as well, and we've got a few questions to run through. The first one's probably for you, Nicol, and I'll combine Alex Murray's and Simon Oldham's, and that's really, will you be publishing the updated data from the work you've been doing, and when, and also will you still be looking for on-the-ground validation of the data that's been produced by your algorithms?
First of all, yes, we will be publishing it, and I haven't got a date that I can give you tonight. I will definitely be publishing it imminently though, and it's just once we've cleared the briefing with the Minister and everything's teed up. In terms of the additional validation, it was really good what people did. We were getting drone data sent to us, and folk were obviously using the app. But I think we've recognised we're probably now in the limits of what we can do with the data. So while it's still helpful to understand areas that we've missed, it's not known that there'll be specifics. It's this issue about where you draw the thresholds, because you're then into the territory of you're starting to get false negatives and false positives, and they go up in magnitude of order. So I think it would still be useful to get feedback, but I'm not sure that we'd necessarily be able to produce an awful lot more accurate map without an awful lot more set of eyes looking over it to check it. And I should have mentioned when I was talking, to give you a sense of how much this has cost to do this Storm Harbour work, you're probably looking at a low five-figure sum, somewhere in the order of about £30,000, £35,000. And that's only able to do because it's my staff's time. All the data we're using is given to us free through ESA.
No, thank you. Next one is, what are the prospects for assessing forest health remotely? And that's come from Crispin Golding.
I think the prospects are pretty good. We're not there yet. There will be people out there who claim that we are. I don't think, well, certainly not in British forestry. I haven't seen anyone that says that we definitely are. And but I think in the next 3 or 4 years, and what we're actively working on at the moment is using the hyperspectral to assess stressed trees, and that's active research work that we've got ongoing at the moment. And if it was something that would be of interest, I could ask Juan Suarez to come and give you a talk about that whole topic.
Sounds good. Like another presentation for a later date. Like the sound of that. Simon, Stuart, I think you both touched on this at some point in your presentations. Simon's, I'm assuming you can use LiDAR information along with OS data to get accurate crop heights, or can you use LiDAR to produce digital surface models and digital terrain models to give crop height?
Well, I'll deal with the first part, and then Ben can explain how he does it. So we've been doing this pilot with LiDAR, but it's like national scale level. It's not with drones. We're looking to use the EA information. So Juan, who pioneered all this work, had his own methodology for getting the DSM and the DTM, but they're also surprised this analysis ready straight from EA. So we did some work on that and realised that actually we could save a big step and reduce our costs input by using the EA supplied DSM and DTM. The issue that we had was getting hold of all of the data, because it's a bit fussy to try and get the data down the way they've got it. So we've actually just literally this week got all of the LiDAR data for the whole of England now, so we can cut out all of that process. The other thing that we noticed, and apologies if folk aren't that familiar with the technology, but the way it works is what they call point clouds, and the point cloud density, as you can imagine, at an operational scale data collection across country level varies. So what we've been looking at is pulling together a heat map for where the point clouds aren't as dense and there might be some issues. And what we are proposing is that we could then fill in these holes with drones and stitch the data in so that we could do the national level. Well, what we're looking to do is forest plan level assessment so that people can have key mensuration data. So that's essentially what's happening, and it's the same in Wales. They're doing analysis ready DTM and DSM. So again, all that happens is you're working out the height of the tree based on the point clouds and the DTM.
Good.
Yeah, I think I've had similar experience. I've worked with the EA point cloud before, and it's really quite easy to use if you have the right software to work with it. We're actually in the private sector in Scotland, at least, we're slightly constrained by licensing in terms of using the point clouds, because SEPA make all of the LiDAR data available, but the point clouds are actually licensed slightly differently to the process DSM and DTM. So the DSM and DTM are under an open government license. I'm hoping Nicola will correct me if I'm wrong about any of this, but I think we can use that with attribution So it's basically the only free option we've got. So I've done quite a bit of work mapping tree heights with the process DTM and DSM, and just literally subtracting the two. So it's essentially, it's a grid of numerical values. I mean, GIS will map it as a picture, but essentially all it is a grid of equally sized squares that are stacked on top of each other, and you can just subtract the two, and then that's effectively your tree height. Most of the SEPA data is a 25 centimeter resolution, so you stand a pretty good chance of capturing the middle of some of your tallest trees. And from the ground truthing that I've done on it, I've found it to be pretty accurate. And it's one of those things where you don't know which one's more accurate, your clinometer on site or the LiDAR, because both have inherent kind of flaws in the.
We've benchmarked it against Harvesting Head data, and also Dave Woodhouse did some benchmarking with us in Kintyre, and I would just echo it's remarkably accurate. It really is, and it's certainly more than good enough for operational reasons, purposes.
Yeah, and for yield class as well. I mean, yield class is a pretty big bracket in terms of division of yield class. And I've just seen the question about reflying at intervals as well. And Nick will have a different perspective for using LiDAR alone for inventory, but certainly for kind of my position on LiDAR is once you've got that LiDAR data once, you've got the sub-canopy terrain, and then you've got all sorts of other approaches you can use to stack data on top of that. And that's kind of where I was coming from with the drones, is that if you've got a single LiDAR data set for your forest, which a lot of us do in South Scotland already, then you can fly any compartment with a drone, and as long as you can marry those two data sets up, then you can extract tree heights to some degree of accuracy.
Yeah, well, what we're doing is the plan is to fly the LiDAR data every 5 years. I think it is in England. It's maybe three to 5 years, so we can grow the trees using growth models over time. So we're pretty comfortable we can use up to 5-year-old data. I mean, this goes back to my point about dynamic data sets. A lot can change, so over 5 years. But if the crop's relatively static in terms there's not been too much wind blowing, obviously felling we can easily take out with the woodland loss algorithm. We're quite comfortable we can use up to 5-year-old data.
Good, thank you. We've got another couple of questions in quickly. One for a couple for Ben actually. A question for Ben from Gert. Ben, how do you propose to measure the stem diameter of a large area when not using LiDAR and just relying on two different photogrammetry terrain models? Sorry.
That's an easy one. I wouldn't propose to do that with the drone. I think that's beyond what we can do certainly with the current technologies. I know there are drones that can fly kind of under canopy and kind of indoors, but it's not the kind of relatively low cost ones we're using generally at the moment. So drones are a great way of establishing top heights, getting yield class information, but for doing kind of full tariff assessments, there would need to be some kind of ground-based system as well. Yeah.
No, I have a question for John Gorman for you, Ben. Obviously looking to get some payback for using the SEPA LiDAR data. Is there a simplistic technique whereby source waters for private water supplies can be easily mapped via soil moisture or soil temperature differentials and/or vegetation changes for new woodland planting schemes?
That's a really interesting question, and I'm afraid I don't know the answer. I don't know how much kind of, in fact, John, you probably know more than me, but about how kind of normal variations in soil moisture would kind of throw up kind of noise in any kind of algorithm you have to detect private water supplies. Yeah, maybe it's something we should be looking at.
Thank you.
Sorry, Eddie, can I just pick up on a point that Ben's made? I think what I'd just like to say is that I think what we're illustrating today is how the technologies can work together, from satellites to LiDAR to drones to handheld geoslams or whatever device you might want to use. And I think the trick that we're going to have to develop over the next 2 or 3 years is just to finesse how they're all going to work together. And I don't see them being competitors. So if you take an example, and one that we're actively working on at the moment, if I was to take a forest plan in Kintyre and run it with the EA LiDAR data, we know it wouldn't be 100% accurate. There would be holes or areas of. That's where you then potentially bring in the drone, and you might also then want to do some further ground truthing just to validate the models that everything's running on. So I think that the finessing that we've to do as an industry is to work out how all these technologies are going to work together. I've got ideas, but I'm sure plenty of other folk have got good ideas as well. And it'd be really interesting to just work with folk around all of that. And I think what we did with Storm Arwen is a very good example of how we can work together collectively to get some really good results pretty quickly.
I can just add to that as well. I think that having a diversity of kind of technologies as well is a really good way of eliminating bias from a sort of data science perspective. There'll be areas of wind blow, for it to use that example, that will be inherently more likely to be missed by the wind blow algorithm for one reason or another. So by ground truthing that with them, well, literally on the ground or using drones or something, you're minimizing that bias between the two technologies. And that's especially important where there's models that are feeding into either inventory data or like for mapping clearfells as an example. If the clearfell algorithm is being trained on the National Forest inventory, but the clearfell algorithm is also informing the National Forest inventory, then clearfells that are less likely to be detected then become less likely to be in the inventory. And that kind of bias is perpetuated, and that can be broken. That cycle can be broken by combining it with kind of different approaches.
Good. A couple of very, very quick ones before we bring things to a close. I missed one from Jamie earlier on, basically asking about the quality of the LiDAR data. I'm trying to find the message. How good is your satellite imagery compared with that used by the MOD? And how much would it cost to cover Scotland with LiDAR?
Okay, well, the quality of the satellite image depends on the height it's flown. So Sentinel's flying about 700 kilometres, but there are other providers like Capella which fly lower but have higher resolution. I won't pretend I know what the MOD are up to, but I suspect they've got satellites up in space that can do all sorts of things that are heavily protected. What I will say though is Sentinel 1C is scheduled to take off into orbit later this year, and I think Sentinel 2C is scheduled for 2024. So they're sending satellites up all the time, and each generation of satellites are going to be better than the previous generation. That's just usually the way of it. So I hope that answers your question, Jamie. And then in terms of how much would it cost to cover LiDAR, I was quickly hopping around my notes to see if I could find it. I did do something for FLS a couple of years ago, and I think the figure in my head was about 1.8 million but you would be over 5 years, so just over whatever 300,000 a year.
Thank you. A couple of questions from Alex Murray again just before we finish up. Alex seems to think you're cheap for what you do, and I'd probably agree with that, the services that are provided. And he's really just asking, are your team available on a charge-out basis to the private sector?
Yes, good to hear from you, Alex. It's been a while, but yes, absolutely. I have no shame whose money I'm prepared to take. So good.
Well, thank you both very much for that. Well, 3 very interesting presentations which have shown us what a dynamic industry we work in at the minute, from the changes in technology and also the changes in woodland carbon and the impact that's having on everything that's going on. I would just like to sort of bring things to a close and really once again sort of make everyone aware. Obviously this is going to be Jamie Farquhar's last meeting officially. He may join us in the future just to hear what we're up to, hopefully, but Jamie will be retiring very shortly, end of next week, I think, Jamie. And I'd really just like to thank Jamie again personally and on behalf of the industry for his enthusiasm and support he's given us over the years, and wish him all the best for whatever he gets up to in the next stage of his life. And I think I'm correct in saying that Jamie's replacement, April Armstrong, is actually on the call. I'd just like to welcome April, and I don't know if she wants to switch her camera on and say hello to everyone or is being shy, but good to have you on board, April. I look forward to working with you in the future.
Thank you very much. I really appreciate that.
So welcome, April, and thank you, Jamie, and also thank you very much to everyone else, especially those who have presented tonight, from Andy on the carbon, and then Nicol and Ben on the use of technology, how we can use it smarter and better within the industry. And I think that's really it from me, apart from to say thank you to the rest of you for your time tonight and listening to our presentations. Hopefully you enjoyed it and got something from it. I look forward to seeing you again next time, if I don't see you in the meantime. Thank you very much.
Thanks, Eddie, and goodbye, everybody.
Thank you, Jamie.
One quick point for anyone. I did post up on the chat. The recording will go on to probably the Confor website later, and I did post in the chat a link to Andy Baker's previous presentation back in October to Mid Scotland, which goes into a bit more detail of the minutiae of the Wood and Carbon Code. So anyway, good night all.
Thank you, Jamie. Good night.